Rank the following from least reactive to most reactive towards a nucleophilic acyl substitution. So these are the sorts of reactions that our carboxylic acids and carboxylic acid derivatives undergo. And so what you're looking at here in a nucleophilic acyl substitution is you can essentially think of whatever is attached to the carbonyl carbon as your leaving group that needs to be replaced by a nucleophile, so that overall, we'll just use Nu to represent the nucleophile. You're going to be doing this sort of replacement. And so that means that your leaving group is going to be lost as an anion, or possibly if you've got an acid catalyst, it might be neutral. But let's just, if we're comparing these, let's just consider that we are using the same anion to displace all of these. So what we want to do is we want to compare the leaving groups. So the least reactive would have the worst leaving group. And so that means it would be the strongest base when it leaves, because good leaving groups are weakly basic or neutral. So your most reactive would have the best leaving group or the weakest base. So what we have to do is we want to identify what is attached to the carbonyl carbon on each of these structures, and imagine what it would look like if it leaves and gains another a negative charge. Or in the case of this first one, it would gain another negative charge. So your leaving group here would have to be O2 minus. And so that should really kind of raise your eyebrows. We have never seen this as a leaving group, because this is a really, really, really terrible leaving group. So this is actually the worst leaving group out of all of these that we're going to see. So this is the carboxylate. So carboxylates are the least reactive carboxylic acid derivatives. And so you'd form these anytime you're trying to do a reaction with a carboxylic acid itself and you're using a base. It's going to deprotonate it and give you the carboxylate. So that is a carboxylate ion. So this is our least reactive. So right off the bat, we have found the least reactive. And then to rank the others, we still want to keep comparing by the leaving group. So if we are looking at number 2, this is an amide. Then your leaving group in this case would be NH2 minus, which is also a really strong base. This is the base that we tend to use to deprotonate a terminal alkyne. And it's the conjugate base of ammonia, and ammonia itself is a base, so then it's the base of that is even more basic. So this is a really strong base. But let's get all of these listed so we can compare. So here we have an acid chloride, also known as an acyl chloride. And so here we have as a leaving group is Cl minus, and this is a really, really weak base. So this is a strong base. This is a very weak base. Right, chloride ion is the conjugate base of hydrochloric acid, and we know that hydrochloric acid is a strong acid. And we also know the relationship between acids and conjugate bases. If you have a strong acid, you have a weak conjugate base. All right, and for the last one, we're going to lose as a leaving group here. If this were to leave, you would lose the alkoxide. Right, so this is also a strong base. All right, so we found our terrible leaving group in the first one. And this functional group here for 4 is an ester, so we should label that. So we found our terrible leaving group. Here where we have a weak base, this is our most reactive. So this is we found the least reactive. Number 3 here is the most reactive. And then we want to compare our amide and our ester. So if we're looking at the leaving group, you're comparing a negative charge on nitrogen to a negative charge on oxygen. And the negative charge on oxygen is going to be more stable because oxygen is a more electronegative atom. So this is a strong base, but it's not as strong as the amide. And you might also compare this by looking at the conjugate acid, right? So if you remember some of your pKa values, if you're dealing with an amine, you're looking at a pKa in the range of 35 to 40. And if you're looking at an alcohol, right, like this methanol, you're looking at a pKa somewhere in the ballpark of, say, 15 to 16. So that actually is a really, really big difference. So now we want to go from least reactive to most reactive. So we know the least reactive is number 1. And so we're going to say that carboxylate is less reactive than the amide, which is less reactive than this ester, which is less reactive than the acid chloride. And so the acid chlorides are our most reactive carboxylic acid derivatives that we're going to see. So this order here is matching up with D. So that is our right answer.